Find the length of each unlabeled side. Segments AB and EF are parallel. AB is parallel to EF, AD is perpendicular to DB. Okay, so because we have this side, AB, let's do this in red. Because we have this side, AB, parallel to this side, EF, that means we have similar triangles. So we can write a similarity statement, triangle, and here's ABD. ABD is similar to triangle, EFD. So that means we have proportional sides. So we can use our similarity statement to write the proportions. AB is the first two letters, over EF is the first two letters, AD, first and last letter, over ED, first and last letter, and then BD, second and third letter, FD, second and third letter. So that's our first step. Our second step is we already know some of these pieces of information. We already know what AD is. AD is 3. We already know what BD is. BD is 4. And we already know what ED is. ED is 7.5. So let's fill in what we already know. So AB, we don't know that one yet. EF, we don't know that one yet. AD, we know that one's 3. And then ED, that one's 7.5. And then BD is 4. And FD, we don't know that one yet. Okay, so now we should be able to start solving some of these. The first one we could probably find the easiest is going to be FD. So I'm going to do that one over here. I'm going to use just this part of that proportion to say that 3 over 7.5 equals 4 over FD. Now, there's lots of different strategies for solving proportions, but the one that I'm going to use is I'm just going to use cross multiplication. So I'm going to say I can cross multiply like this and say that 3 times FD equals 4 times 7.5. And now I can divide both sides by 3 to cancel these out, so that FD is going to be whatever 4 times 7.5 divided by 3 is. So let's get the calculator here and go back to here. So I want a little bit bigger. There we go. So I want 4 times 7.5 divided by 3, and that's going to give us 10. Okay, so now we found FD should have a length of 10. Okay. And now we can actually use this information to find the length of FB, because if this is 10 and this is 4, that means this side must have a length of 6. Okay, and now we're looking just for the last one. So in order to do this one, I actually don't know what AB is, and I don't know what EF is either. So I'm going to have to use some information here from this triangle. The fact that this is a right triangle tells me that I can use Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. And in this case, my a value is 3. My b value is 4, and I don't know what my c value is. I can plug these in, so this is going to be 3 squared. So we got 3 squared plus, replace the b with the 4. 4 squared equals c squared. So now we can use the calculator if we wanted to for this. So we're going to have 3 squared plus 4 squared. That's going to give us 25. So 25 equals c squared. And now we would need to take the square root of that. So square root of 25, that gets us 5. So 5 equals c. So now I know this side length right here is c. So now I can use this information because that's AB. So I can go over here and say, instead of AB, let's put the length of 5. 5 over EF equals 3 over 7.5. And now we can solve that proportion. Okay. This time I'm going to use a different strategy. I'm going to use the strategy that says when we have a proportion, we can flip it upside down. So I'm going to rewrite this proportion as EF over 5 equals 7.5 over 3. And now I have EF, but it's being divided by 5. So I need to multiply both sides by 5 to make the 5's cancel out. So now we're going to have EF equals whatever 7.5 times 5 divided by 3 is. So I can do that over here, 7.5 times 5 divided by 3, and that gets us 12.5. Okay, so here is the length of EF, 12.5.